All right, we will be starting now. Hello, everyone, and good morning to all. Dear authors and invited guests, welcome to Technical Session 7A. My name is Dimahi Patel, and I'm the moderator for the session. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 15th December in Jaipur, and the virtual event is being held through Zoom yesterday and today, that is 16th and 17th December 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Now, before we start the session, I would like to introduce you all to the chair of the session. We have with us Dr. Archana Banet. Dr. Archana is an assistant professor in the Department of Computer Engineering at MET's Institute of Engineering, Nasik. She has over 19 years of teaching experience and have organized numerous workshops and seminars and published 8 research papers of international repute. Her areas of expertise include data science, machine learning, DBMS, data mining, and anomaly detection. A warm welcome to you, ma'am, and I invite you to kindly share a few words with us.
We will start the session. At the end, I will give the concluding remarks.
Ma'am, we are not able to hear you.
Hello? Hello? I am audible now? Hello?
Yes, you're audible now. Hello.
Ma'am, we will start the session and at the end, I will give the concluding remarks.
Okay. Sure, ma'am. So we will be starting with the presentations now. I would like to call Hemlata Gaikwad to present her study on a review on use of AI in stress management among Gen Z. Hemlata, ma'am?
Good morning, ma'am. On behalf of Dr. Hemlata Gaikwad, ma'am, Professor Manali here, I'll be presenting today's presentation.
Okay. Sure, ma'am. Please start with the presentation.
Yeah. Ma'am, I'm not able to share the slide.
Ma'am, can you please try again?
Is the screen visible, ma'am? Hello?
Yes, we can see your screen, ma'am.
Yes. Good morning. Good morning, respected panel members. I, Professor Manali Bhosle, will be presenting today's paper on today's presentation on use of AI in stress management among Generation Z. So coming to the abstract, stress level among Generation Z have increased significantly due to academic pressure, digital exposure, and changes. We have seen like many of Generation Z is been struggling from stress issues just because of the maybe they have less patience and all that stuff. So the study will explore how AI tools will help Generation Z to manage their stress. The research follows a qualitative approach using in-depth interviews and thematic analysis to understand the experiences of Generation Z. It also examines effectiveness but ethical concern related to AI in mental health. So the overall study will aim to contribute insights of how AI will support emotional well-being of young generation, specifically Generation Z. The major components which used in the study were stress management, Generation Z, mental health, mental well-being, emotional well-being. So the keywords reflects both the technological and psychological dimensions of the research. Coming to the introduction of the study, Generation Z specifically born between 1997 and 2012, is experiencing high stress due to factors such as digital media exposure, academic competition, career uncertainty. So we have experienced many youth or many Generation Z who are struggling just because of their career pressure, maybe the academics. So, as we all know, traditional stress management methods may not be help this generation, as this generation is mostly addicted to the techno. This generation is mostly techno based addict. Since AI is deeply integrated into daily life, it has emerged as promising tool in mental health support. So the purpose of this study is to explore how and till what extent Generation Z can use these AI-based solutions to cope up with their stress and how they can manage their stress level using AI. Means AI will be a peripheral role in managing that stress. So to ensure diverse and unbiased perspectives, participants were selected from different demographic backgrounds, such as students, young professionals, urban and semi-urban populations. This study used purposive sampling, which is a non-probable probability sampling technique. Um, so this approach allows us to select participants who provide rich, meaningful, and relevant data based on the experiences of AI based stress management tools. Means to like avoid the biasness or some people who don't belong to Generation Z may not be uh, relevant to the study. So this particular sampling was used. Uh, so here, a phenomenological research design, which was focused on particular individuals' experiences. So, like every individual has their own interpretation. Like everyone has different definition of success. Likewise, everyone has different level of stress management or different understanding related to stress. So this design was built and sorry. So this was closely aligned with our objectives for understanding how Generation Z experiences AI based stress management, like how stress is deeply personal experience and how effective the AI tools vary from person to person. As the level of stress vary from person to person, the use of AI or the purpose to use of that particular AI of person to person may vary. So to conclude, this study adopts a qualitative, interpretive approach to explore the experience of Generation Z in using AI for stress management. Though purposive sampling, semi-structured interviews, thus research aimed to provide meaningful insights uh, to maintain an ethical rigor. So this approach allows participants to understand both how how AI would help them or how AI helps them in managing the stress. Yes, thank you, ma'am.
Archana ma'am, any questions? Ma'am, we are not able to hear you. All right, if there are no questions, we'll move on to the next presentation. Thank you so much, ma'am.
Thank you, ma'am.
Now, next, I would like to call Varshant Reddy to present his study on decentralized identity management system using blockchain.
Yes, ma'am. Can I start sharing my screen?
Yes, sir.
Yes. Yes, ma'am. Is my screen visible now?
Yes, sir. Please start with the presentation.
Yes, ma'am. Yes, ma'am. Yes, ma'am. Good morning, respected panel members. So, myself, Varshant Reddy, here to present a presentation on a conference for decentralized identity management system using blockchain. So, before I begin with uh, before I begin with my topic, let me start with a real life problem that we face today. Every one of us uses multiple online services like maybe banking apps, government portals, universities, hospitals, and social platforms. And each of these systems stores our identity details in a centralized database. Even if one of these databases is breached, our personal identity information is permanently exposed. So we have seen several incidents where a million of identities were leaked single due to single point of failure. The core issue here is that users don't own their digital identities, organizations do. So this motivated us to do this work. So where we proposed a decentralized identity management system using blockchain, where users have full control over their identities and trust is ensured through cryptography and blockchain rather than centralized authorities. And coming to the problem statement, so first we have traditional centralized identity systems suffer from multiple limitations. First, they have single points of failure, meaning one successful attack can compromise millions of identities. And second, they have limited control over how their identity data is stored or used. Third, data lifecycle events such as creation or revocation are transparently verifiable. So, as digital interactions scale rapidly, there is a clear need for identity system that is secure, privacy preserving, auditable, and independent of centralized authorities. So, the project addresses these challenges using cryptography and blockchain technology. And coming to the motivation part, the thing that mainly motivated us is that the increasing number of data breaches and identity misuses incidents in the centralized system. Users are required to trust third party organizations with their most sensitive information, yet they have little visibility or control. So, our motivation is to design a users own their identities, security is ensured, and trust is derived from transparent and tamper proof mechanisms. So, coming off to the summary of the existing research or the literature survey, existing research shows a strong shift towards decentralized and self sovereign identity systems using blockchain. Prior works explore authentication, decentralized identifiers, and verifiable credentials, highlighting benefits such as privacy and tamper resistance. However, like many of these approaches face practical issues such as high integration, complexity, scalability problems, lack of real-world deployment, and poor usability. So these gaps highlight the need for a practical, lightweight, and deployable decentralized identity systems, which directly motivates our proposed approach. So this is like a short brief about our literature. I mean, like the Arctic diagram or something. So coming to the system architecture, a system follows mostly a three-layer architecture: the application layer, the cryptographic layer, and the blockchain layer. So the application layer provides with a browser-based interface using HTML, CSS, and JavaScript for user interface and user interaction. Then the cryptographic layer, where we used security operations such as RSA for key generation, hashing, and digital signatures. Coming to the blockchain layer, we have used Ethereum smart contracts to log identity lifecycle events and immutably. So the backend is implemented using Python and Flask, which connects us users' actions with the cryptographic processing and blockchain integration. And coming to the cryptographic design and identity representation, as I already discussed, so RSA with a 2048-bit key size is used for the public private key generation and digital signatures. And then SHA-256, SHA-256 is used for the hashing messages and documents to ensure the integrity and tamper detection. Moving on to the identity and workflow operations. During identity creation, an RSA key pair is generated, the private key is encrypted with a user password, and then creation event is logged on the blockchain. So for signing, the input is hashed using SHA-256 and signed with the private key. And for verification, the public key is used to validate the signature, and verification fails if the data is modified or identity is revoked. So identity revocation invalidates further signing, and verification is permanently recorded on the blockchain. And moving on to the blockchain logging and logging evaluation and ethics. So we have used Ethereum smart contracts as a decentralized audit trail in our system. So they store only encoded references and timestamps for identity creation and revocation events. So no personally identifiable information is stored on the chain. The system was tested for functional correctness, tamper detection, and blockchain synchronization. Ethical considerations, we have included the user consent, encryption, pseudonymity, and full user control over the identity lifecycle. Now we could go to, I'll give you a short run through over my results. So we can see the identity creation step by step, and then signing a message. Then we have also included a document signing. Then if we are successful going in through the signing off, then we get a message of successful verification and we'll get verified. And if we fail or some breach, if it senses some breach or something, it directly gives a failed verification or digitally signed message indicating for the documentation. And yeah, this is for, yeah, as I said, document verification has failed here. And yeah, coming to the conclusion. So to conclude this, we have demonstrated a practical decentralized identity management system that removes reliance on centralized authorities. So by combining RSA cryptography, SHA-256 hashing, and blockchain-based auditability, the system enables secure, transparent, and user-controlled digital identity management. So the results confirm reliable tamper detection and correct cryptographic behavior and consistent blockchain synchronization, making the system suitable for future decentralized digital ecosystems. So yeah, thank you for your time and attention, and I'll be happy to answer any questions.
Ma'am, any questions for him? All right, ma'am has written her question in the chat box, I assume. Sir, can you please read the question and answer it for ma'am? Varshant sir, am I audible? I repeat,
I just
Varshant.
gone through. Yes, ma'am, I'm here.
Yes, yes.
What are the major challenges in implementing blockchain-based identity systems at national or enterprise scale? So, mainly, ma'am, we face scalability and performance issues like public blockchain process transactions slower compared to the centralized system. So at a national or like enterprise level, identity systems may need to handle millions of users and frequent identity events. So which can even lead to latency and throughput limitations. So this makes a scalability and a key, scalability and to handle such a huge number of people, it makes a bit issue with the scalability and performance issues. And also, when it comes to the integration with the existing systems, so most organizations already use legacy identity infrastructures. So integrating these with the decentralized solutions with existing databases and authentication systems, so they make a huge complex work which is not feasible with the existing works.
Sir, ma'am has asked how would you overcome this?
Okay, how? Yes, ma'am. So if we wanted to overcome this scalability limitations, I think we should avoid strong identity data or performing like heavy computations on the blockchain. Instead of using heavy cryptographic operations such as key generation, hashing, signing, and verification, so we can minimize the security level to a locally at the application level. So the blockchain is used only to log essential identity lifecycle events, which significantly reduces the transaction load and improves the system responsiveness. Okay, ma'am. Thank you for your remarks and all. Thanks a lot.
Yes, thank you, sir, for your presentation.
Thank you, ma'am. Thanks a lot.
Next, I would like to call Naresh Kumar Joshi to present his study on design and analysis of an opposite rectangular patch frequency reconfigurable monopole antenna. Naresh, sir. Or any of the co-authors who can present this paper? I repeat, Naresh Kumar Joshi or any of the co-authors. Alright, we'll move to the next one. Hussain Sheikh. Hussain, sir, are you here with us? Rashmi Shivanaduni. Rashmi, ma'am?
Hello, ma'am.
Yes, ma'am. Please
Yes, ma'am.
present your study on development of spatial domain algorithms for feature detection in MRI scanned images.
Ma'am, are you able to see?
Yes, ma'am.
Thank you, ma'am. Good morning, panel members. My name is Rashmi Shivanaduni. So I want to give the presentation on development of spatial domain algorithms for feature detection in MRI scanned images. Firstly, I want to say something on the abstract, like what is meant by MRI, where it is going to be used. So MRI is nothing but magnetic resonance imaging, where it is one of the important images of the body interiors, especially I can say the soft tissue, that is brain or the spinal cord or the other organs. It is mainly used to detection of some important aspects like tumors or organ boundaries in MRI images. So currently, I want to give what the my research paper is going to say. Like here, spatial domain algorithms could be capable of locating some characteristics of MRI images. For this, I have I want to use the primary methods like edge detection, region-based segmentation, and the third one is a morphological operations. So working mechanism of each method will give the advantages as well as the disadvantages of each method. So here the feature detection is going to take taken as a consideration in this paper. So coming to my keywords, I have included MRI in magnetic resonance imaging. Second one is the spatial domain algorithms. Third one, edge detection. Fourth one, region-based segmentation. Fifth one, morphological operations. And the sixth one is feature detection. And the last seventh one is the medical imaging. So these are the keywords. For overview, I want to give like why MRI, what are the challenges, issues on based on that, and what is the solution behind spatial domain algorithms, and what are the benefits of this. So firstly, like I want to give the introduction part of MRI. As I said, it is going to give the important images of the body interiors, and also it is going to give by this we can create a very clear images of organs or the tissues, and also it is going to find the disease early without the surgery. So, and the moreover, I have included the feature detection here. So it is means that finding the important parts in the MRI images, like the mainly it is going to include like edges of the organs or the tumors. So uh, the spatial domain algorithms, why I'm using the spatial domain algorithms, nothing but it is going to work directly with the colors and the brightness of the pictures. Like I can say dots, nothing but pixels, so that doctors can easily or identify, or you can say do analysis by the images. So this paper going to explain how the simple techniques will work with the different methods. The first one, I can say why the spatial domain process is used. Especially each pixel within the digital image contains a numerical value. The numerical value which indicates like the brightness or the intensity. So here the big advantage of using the spatial domain processing, like where the doctor or the physician can look into the process result and easily understand what was the change has been happened. So for MRI images, the key operations, as I discussed, like edge detection, region-based segmentation, and the morphological operations. So this is about why the spatial domain processing is going to be used. These are the three techniques: edge detection, region-based segmentation, and morphological. Firstly, what is meant by edge detection? It is nothing but if I take an example of the tumor, I can find the outline of the tumor, and also I can say where the organs ends and other begins, so that the borders can show up the sudden changes in the brightness of the image dots. So here I have used certain operators. The first one is Sobel operator, second one is a Prewitt operator, third one is a robust cross, and the fourth one Canny detector, uh, Laplacian of Gaussian, zero crossing detector, and difference of Gaussians. Firstly, I want to say Sobel operator, which is nothing but the common and the old method where the simple math filter is used, and how it is going to give how quickly the brightness changes from the left to right, and I can say from the top to bottom. So the changes will be in the fast, and also can draw the edge also. The second one is Prewitt operator. It is similar to Sobel, but different math filter is used for this. And the robust cross, it looks for edges of an diagonals instead of left to right, top to bottom. But it's take instead of straight lines, it is going to take in the diagonal way. So I want to say the best operator or the detector is the Canny for this, because it is a advanced and also reliable method where you have where we have the several steps, like firstly, if we are taking the image, the first step is to gently blur the image to reduce the noise. And the second step, I can say like it finds where the brightness changes to locate the possible edges of the picture. Then it is going to thin the edges down to find, and like nothing but we can get the precise lines or the borders, I can say. Finally, when the lines are connected to a strong, we can see the clear edge of that. So this is a excellent, I can say excellent in finding the real image. So moving to region-based segmentation, this is one second method where we have certain operations or the parameters like region growing, region-based segmentation, and region splitting and the merging and Markov random field. So firstly, I can say what is meant by image segmentation. It is nothing but the name indicates where the process of dividing an MRI picture into different parts so that so that we can see the uh, clear things like organs or the healthy tissues. The first one is region growing. Nothing but it starts from selected seed points so that it is going to add the pixels, neighboring pixels to the region so that that so it is going to until the more pixels are found. Second one is split and the merging. It's nothing but like it cuts the whole image into the squares and it joins the neighbor squares together to look the same until unless the uniform has been appeared inside the image. The last one is the Markov random field. Here, this is it is an advanced method where it is uses other relationship to get the more accurate segmentation. The third method, morphological operations, where we have dilation, erosion, opening and the closing. So we should know what is morphological operations here. It is nothing but where it is going to modify the images or the structure of the image, and also it is going to be work on the simple black and white images. Nothing but when we are seeing the object in one color, the background is the another color. Like if you are seeing the object in the white color, the background will be the black color.
Ma'am,
So
gentle reminder that you've crossed 9 minutes.
sorry. Yeah, should I skip or
You have 1 minute to conclude your presentation. Please try to
okay.
conclude it by then. Yes.
Okay. So coming to the performance evaluation matrix, here I have used dye symmetry, sensitivity, specificity, and the Hausdorff distance. For this, the most clinical applications like we are using in the neurology, oncology, orthopedics, and the CAD system, mainly to quickly identify the problem where the on the scans. Coming to real world or the I can say where it can be used, like it's going efficiently work on basic computers and also emergence in the traumas and all. Mostly effective in giving the solutions based on AI. The current limitations, like here, noise sensitivity is nothing but confused by the blurry spots. Uh, intensity homogeneity causes errors, nothing but here where you can adjust the settings also. Manual parameter we can require here, and also to get the nice workflows where it is used. And the future detections like adaptive operations has been used, like where automatically adjust their settings based on the image. It is used for the semi-supervised learning, nothing but it is going to fix like expert image analysis for unlabeled ones, and explainable AI systems where um, it is going to um, it is going to help for the doctors in such a way by using the techniques. The last one is multimodal image integration, nothing but where the CT scans and the PTS were used to give the complete pictures of the disease. So conclusion I want to give, like it's a by using the spatial domain algorithms, we can improve our diagnosis by using the three methods like edge detection, region-based segmentation, the morphological operations. So this is a conclusion. Thank you.
Thank you so much, ma'am. Dr. Archana, the session chair, is asking you, what are spatial domain techniques and how do they differ from frequency domain methods in MRI image processing?
Like I can say, the spatial domain processing is going to work on the pixel values by adjusting the brightness, and also I can say that comparing the neighbors to find the edges. The frequency domain in processing nothing but where it transform the image to certain patterns.
Any other questions, ma'am? She's asking you focused on frequency domain.
Frequency domain, not just I want to say like first the image or the pixels is going to transform into the image to give the representation of the patterns. Nothing but I have said already, like in spatial domain, the edges or the regions, same as on the patterns. In spatial, it is going to work directly on the pixels or the values of the images.
All right. Thank you for your presentation, ma'am.
Thank you so much, ma'am.
So next, I would like to call Manav Thakur to present a study on Focus Plus, detect learners' distraction by web camera and distance teaching. Manav, sir, or any of the co-authors? Ramya ji, please present your study on healthcare liver cancer prediction using ML and DL.
Yes, ma'am. Can I share my screen, ma'am?
Yes, ma'am.
Is it visible, my screen, ma'am?
Yes, ma'am, we can see your presentation.
Yes, good morning, everyone. Myself, Ramya. Today, my topic is healthcare river cancer prediction using ML and DL. Here, the main aim of this presentation is you can using for the main goal is to predict the major. You can predict the cancer. Here, the main abstract is now I'm going to the abstract is liver cancer is majorly causes of the prevalent and the factorial malignancies of the worldwide, largely due to the absences of the clearly early stages synaptic and the limitation of the existing screening techniques. As the result of the most causes of the diagnostic the advanced stages of significant reducing the treatment success as the patient survival rate. Recently advanced in ML, you can using into the challenges in enabling to earlier more accurate to detect the personalized and the risk assessments. Here the main investigation of this abstract is the application to advance the computational model and including the learning frameworks. Here the majorly you can using into the clinical and the radiological and the biochemical of the data while eventually large scale of the data employing the effective more features of selection model optimization stages. These algorithm majorly you can using into the ML and the DL technique diagnostic the workflows as the potential of the significant enhancing the clinical data and the decision making to automatic in labor in intensive process, reducing the diagnostic variability and provided the consistency of interpredictability results. Here majorly you can using into the additionally personalized to predict the model can be supported to early investigations and trials of the substantial potential in intelligence computational systems to reviving the liver cancer stages. ML and DL is based on the approaches to represent the crucial steps toward the more effective and the effective liver cancer to global scale. While coming to the introduction part, you can using into the majorly the global burden of the liver cancer is particularly HCC. HCC means hepatocellular carcinoma are the one of the majorly leading the causes of cancer leading deaths in worldwide. The major reason of this high modularity rate that can be usually does not show the symptoms to early stages. The causes of more patients diagnosed only when the diseases has been already progressed by the time of the treatment options are the limited, are the survival rate of much lower too because of HCC can be developed into the complex was the various greatly between the individual. There was the urgent needed to accurate scalability and the detection tools that can be detected to the diseases before the symptoms of the appears. Why the ML and DL can be more important because of the it will be early detected or artificial intelligence, especially ML and the DL. The technologies can be analyzed to very large complex of the data set. More the data set can be that can be humans can be processed them manually. The allows the AI can system to discover the pattern that traditionally is statistically methods can be missed. Here you can using into the more different models can be used to in our research purpose that can here majorly used into the different data can be handling such as like data collection, data cleaning, data pre-processing, data imbalancing, feature selections and emergency. Here you can using into the different AI models can be used such as like a CNN, RNN, machine learning, SVM, all these you can using in these research. The benefits of research you can using into the either you can using into the either early detection, improving the diagnostic accuracy, or personalizing risk assessment, clinical decision supporting are the majorly challenges of AI to liver cancer. Here you can using in the data can be imbalancing early stages of the causes, purely last stage of the cases you can using into the which can be causes of the biased model, lack of explainability. Doctors needed to understand why the AI model can be prediction integration with the clinical workflow. AI can be must fit the smooth into the hospital system. The patients can be privacy of the sensitive medical data must be protected for the all the times. Here you can provided go through the literature survey. After the literature survey, we have to you can using into the clinical classically you can using into the machine learning models such as you can age, gender, medical history, and the blood tests, liver functioning markers are commonly used for the ML models. Here, the random forest algorithm you can workflow will be non-linear and the complex of the data. Here, you can using into the produce at the high accuracy can be identified the important features. It's showing the output of the models you can using into the wherever the decision tree and the SVM both you can using for the early liver cancer the classification purpose. The SVM is the good high dimensional and the small data set parameters can be turning to require the best results. Now go for the long logistic model you can and else of the or else k nearest you can using into the applied liver disorder data set you can be used. Now reasonable for the accuracy but limited performance without proper in the future selection. The feature selection was the found significantly improving the model accuracy. Wherever you go for the deep learning model for the medical imaging, CNN is you can using for automatically to extract the spiritual future, excellent future for the tumor segmentation for the classification, achieved for the high accuracy greater than 90% of the some studies. For example, achievement CNN model of the output performance radiologist to detect the small early stages of the tumor. CNN and RNN hybrid for combining both the spiritual and temporary features of the dynamic MRI scans. Now CNN plus RNN is hybrid to both two models. You can use it to pre-processing time series and imaging, enhancing and logistical and patience of the data. Here, the major features of the study you can using into the major you can proposal system is majorly features of the study you can using into the examine to compare the different ML model and DL model to predict the liver cancer, highlighting their the strength, weakness, and the practical applications. Explore how can it be incorporated to real healthcare system, improving the early diagnostics, patients outcomes, personalized the medicines. The majorly you can summary of the all these are you can seriously liver cancer, why the detection is difficult, and how the ML and DL is analyzed to complete medical to detect the cancer early stages, strength the different algorithms you can use into benefits of the AI healthcare, such as like you can use it to early prediction, accuracy, personalization, and early detection. The challenges to solve the problem. The basic you can provide it to the early purpose of the as per the literature survey they can find to detect the liver cancer in early, improve the diagnostics accuracy, analyzing the medical images. These are all the you can purpose you can use in these. Now go
Ma'am,
for the results
reminder
while
that you
coming
have crossed 9 minutes.
sorry.
You have crossed 9 minutes. You have 1 minute to conclude your presentation, ma'am.
Yeah, sure. These are the basic results you can using into the liver cancer prediction. As before that, 50 percentage and the 45 percentage you can perform present accuracy. Now go for the overall conclusion of this research. You can use it to help the detective death rate, frequently last stage to detection, and we have to even provide the basic three stages you can provide at the worldwide healthcare. Here the traditionally diagnosis the methods you can find out in order to increasing the accuracy, speed, and the reliability of the liver cancer prediction. Medical settings in this study purpose of a hybrid and data driven framework. The as per the you can currently methods demonstrated to how AI can be ability, and CNN RNN can be adaptability, and all these are you can early to predict liver cancer. These are all my references you can use, and thank you.
Yes,
Yes.
Ramya ma'am, the session chair is asking you what challenges arise due to class imbalance in medical datasets and how to deal with them.
Yes. It's why to the challenges you can provided into the different challenges in AI can be predicted, or the data imbalance, early causes of few late stage causes which can be biased the models, lacks of explainability, doctor needed to understanding model to predict the clinical workflows, and AI models can be fit smoothly into the hospital system. Our patient sensitive medical data can be protected to all these. Addressing these issues necessary for the AI system widely adopted in for the real clinical settings only. Yes, ma'am. Hello. Hello.
Yes, ma'am. Thank you for your answer. We are waiting for the session chair to give confirmation that she has no more questions, and then we can call the next presenter. Archana, ma'am, any more questions from your side?
Can I leave, ma'am?
Yes, ma'am is saying as related to medical issue should be careful. Thank you so much, Rama ma'am, for your presentation.
Okay, thank you, ma'am.
Now, next, I would like to call Shravanti Kuchipudi ma'am to present her study on integral progression of AI to deep learning algorithmic sequences for detection of liver cancer.
My PPT, ma'am. Is it okay, ma'am?
Yes, ma'am.
Good morning, respected chairs, session panel, and fellow researchers. My name is Shravanti Kuchipudi from SR University. Today, I am going to present my work titled Integral Progression of AI to Deep Learning Algorithmic Sequences for Detection of Liver Cancer. This research focuses on how clinical diagnosis of liver cancer can be transformed using modern deep learning architectures. So, coming to my abstract. So in the healthcare sector, the advent of artificial intelligence has led to significant gains in the early detection and identification of dangerous disorders, including liver cancer. The goal of this study is to improve the diagnosis of liver cancer by examining the progressive shift from traditional AI models to sophisticated deep learning algorithmic sequences. Machine learning classifiers and other AI techniques have demonstrated potential in interpreting clinical and imaging data. However, their efficacy is often limited by the intricacy of medical data sets. Complex patterns and features may now be extracted from MRI, CT, and haptic ultrasound images using deep learning models. Specifically, CNNs, convolutional neural networks, and recurrent neural achieve high diagnostic precision by utilizing sophisticated feature extraction techniques and extensive annotated datasets. This study illustrates how AI is evolving toward deep learning paradigms to automate liver cancer screening, better clinical decision making, and improve patient outcomes. These results demonstrate the transformative potential of end-to-end deep learning pipelines in the growth of intelligent, non-invasive liver cancer pinpointing and diagnostic systems. The result is an end-to-end diagnostic intelligence framework that increases precision, reduces radiologist workload, and enhances explainability through visual tumor focus mapping. Next, coming to keywords. These are the keywords: AI, deep learning, liver screening, and convolutional neural networks, RNNs, medical imaging, diagnostic algorithm, feature extraction, and healthcare analytics. So, coming to introduction. In large part, liver cancer remains among the foremost causes of liver cancer related deaths in the worldwide, owing to late stage diagnosis and limited access to special diagnostic equipment. A key factor in rising survival rates and enhancing treatments results is early and precise identification. The information of radiologists and pathologists is often relied upon a convolutional diagnostic techniques like computed tomography, that means CT, and MRI, magnetic resonance imaging, ultrasound, and biopsy. This knowledge is subject to human error and variability. Disease identification, especially in oncology, has gone through a shift in recent years due to the use of AI are integrated with machine learning and deep learning have shown important promise in automating the study of complicated medical data. Initial AI models were unable to manage large varied data sets since they depend on rule-based algorithms. algorithms, and hand-shaped features. Consequently, more dependable techniques like deep learning surfaced. Without recurring human feature engineering, two forms of deep learning algorithms, CNNs and RNNs, have shown an impressive capacity to learn from vast amounts of clinical and imaging data. Liver cancer screening technologies are now more accurate, efficient, and scalable due to the development of complex deep learning models from traditional AI. These models would be able to detect minor anomalies in the imaging information, differentiate tumor edges, and go further to predict the disease progression. Hence, assistant radiologist in making quicker and more knowledgeable choices. This paper discusses the significant advancement and highlights the role that deep learning algorithms are playing in changing the development of intelligent, automated, and non-invasive diagnostic models to identify liver cancer. Next, coming to what are the current issues of the liver cancer. So current issues are late detection. So late detection in initial stages, it is very in initial stages to find out the liver cancer, then the treatment is very effective. In late stages, it will lost one life. So after that, unsure sign, that means initial symptoms such as tiredness, malnutrition are often ambiguous and confused with other illness. Next, picture disservice. Present imaging methods such as CT, ultrasound, MRI scans may fail to detect small tumors are difference between benign and deadly tumors. Next one, coming to sensitivity of biological markers. Current biomarkers such as alpha fetoprotein do not have enough sensitivity and specificity, resulting in accurate result. Next one, biodiversity, microbiodiversity. Differences in tumor genetics pose challenges in finding common diagnostic markers. Limited access to diagnostic tools and healthcare services intermittently detection, particularly in low resource areas. Next, surveillance procedures. Inconsistent detection practices are caused by the absence of standardized screening guidelines for high population. The integration of new technologies such as liquid biopsies displays promises but is not current prevalent in clinical use. Cost and resource limitations. The high expensive of advanced advanced imaging and testing prevent many patients from accessing them. Next, physical awareness. Differences in knowledge and awareness among healthcare providers can result in overload. Diagnostic, psychological, and social factors such as stigma and fear could prevent people from seeking medical help for the liver diseases. Next, coming to literature survey analysis. In this literature survey analysis, a clear progression exists in diagnostic automation. So so first one is early AI. In this, the approach is decision rule system. In this, there is one limitation, that is there is no adaptability. Next one is classical ML. The approach is SVM, RF, and KNNs. There one limitation, that is manual feature extraction. Next, coming to deep learning, that is CNN, convolutional neural networks. In this, there is no temporal progression learning, that is the limitation. Next one, hybrid deep learning. So in this approach, they are having CNN plus LSTM plus XAI. That means convolutional neural networks, late, long, short-term memory plus explainable AI. They are the approaches. In this, they have high accuracy plus interpretability is the limitation. Machine learning introduced automation but lacked reliability due to handcrafted features such as texture, histogram, and edge descriptor. Deep learning, particularly CNN architecture, learned from raw medical imaging, but they did not understand time phase evolution of tumors. This is where LSTM and temporal modeling add value, allowing the system to contrast phase changes in CT sequences over months. Further explainable trust, which is the final missing component of adoption inside clinical oncology rooms. This is a literature survey analysis. Next, coming to existing approach. In this existing approach, in olden days, from manual analysis to machine learning. manual interpretation. Radiologists analyze CT, MRI, and ultrasound scans manually. So that means they are manually doing, that means they are going to consume the time, prone to error and limited for early detection. Next one is rule-based expert system, used predefined clinical rules and threshold, interpretable but lacked flexibility for complex data. Traditional ML, that means SVM, KNN, and random forest. These are relied on manual feature extraction. That means texture, shape, intensity. There is a limitation among generalization due to handcrafted feature extraction textures.
Ma'am, gentle reminder that you are crossing 9 minutes.
Okay, next I am going to proposed method. In this proposed method, there is end-to-end deep learning pipeline they are using, that used for advanced imaging pre-processing, a hybrid CNN LSTM architecture, multimodal data fusion, and explainable AI for accurate liver cancer detection. So by using CT or MRI images, undergo normalization, contrast enhancement, and noise reduction also. And ROI extraction is also isolate relevant tumor and tumor diagnosis. Here they are using soft-max classifier, predict normal, Bayesian, or malignant classes with associated confidence scores. Here, the system is evaluated using k-fold class validation and external data sets, emphasizing sensitivity, specificity, and AUC ROC. Finally, the model is developed through a lightweight inference engine compatible with PSES, enable real-time clinical use. Next, coming to, these are the results in US liver cancer fatality rates from 2008 to 17. These are the results. Next, coming to the effect of help on pathologist diagnostic performance. These are the graph for pathologist. Next, coming to conclusion. In conclusion, liver cancer detection can be drastically improved when AI is not viewed as a replacement but an extension of radiologist capability. The hybrid model demonstrated superior detection accuracy and interpretability. Future expansion include federated learning networks, real-time model development into hospital PSES, and pre-screening triage automation. So this is the overall, the proposed learning-based framework represents a reliable, interpretable, and scalable solution for automated liver cancer diagnosis, significantly contributing to improved clinical outcomes and patient care. So these are my references. Thank you. Thank you for this opportunity.
Thank you so much, ma'am. The session chair is asking you, what distinguishes classical machine learning algorithms from deep learning architectures in medical diagnosis? Am I audible to you, ma'am? Shravanti, ma'am?
Yes, ma'am. Yes, ma'am.
Ma'am, the session chair, Dr. Archana, has asked you a question. What distinguishes classical machine learning algorithms from deep learning architectures in medical diagnosis?
Ma'am?
Yes, ma'am, I believe you have a network issue. Can you please write your answer to the chat box for ma'am?
Yes, ma'am. Yes, ma'am.
Okay, thank you for your presentation, ma'am. Now, next, I would like to call Smitha Sasi to present her study on random forest-based predictive modeling of cotton yield under projected climate variability.
Yes, ma'am. Am I audible?
Yes, ma'am.
Good morning, one and all present here. Myself, Dr. Smita Shashi, Associate Professor and Chair Space Technology Cell, Dayananda Sagar College of Engineering, Bangalore. So today I'm going to present the topic Random Forest-Based Predictive Modeling of Cotton Yield Under Projected Climate Variability. So the main contents about the introduction about the cotton yield prediction, the climate variability and its effects, methodology, why the random forest algorithm and the results, and the field yield prediction and genotype selection and the conclusion. So when come to the cotton yield prediction, the climate variability and the global warming have increasingly affected the cotton production across major agriculture zones. This research study presents a data-driven approach to predict the cotton yield under varying climate change scenarios using the random forest machine learning algorithm. The historical cotton yield data were combined with the climate parameters such as temperature, rainfall, humidity, and the carbon dioxide concentration over multiple decades. The random forest model was trained on this multidimensional dataset to identify key influencing factors and generate yield predictions state that the RF model provides the robust, accurate forest and highlight the specific climate thresholds beyond which yield significantly decline. In this particular model, we serves a valuable decision support tool for the policymakers and the farmers in climate resilient in agriculture planning. So mainly the impact of climate variability, the economic significance of cotton, and the major study objectives. So major study objectives in this particular research work are the data collection. That is the first objective, where we will gather the rainfall data, crop production statistics, soil information, and the meteorological data from reliable sources like satellite imagery, government databases, meteorological agencies like Geological Survey of India. Ensure the data covers the historical trends and the high resolution images for the accurate analysis. And a major climate variability and its facts here, it is affecting the key climate parameters as I mentioned earlier, the temperature, rainfall, humidity, and the carbon dioxide concentration. And the projected climate scenarios will be utilizing the representative concentration pathways RCPS. We can model the future climate scenarios which can predict the how changes in the greenhouse gas concentration which will impact the agriculture practices, where understanding these scenarios is crucial for developing the adaptive strategies for the cotton farming. What is this adaptive strategies? Which is the climate change which continues to alter the agriculture landscapes. There is an urgent need for the climate resilient strategies. The farmers must adapt to these changes through innovative practices that enhance the resilience and ensure the sustainable cotton production. And the second objective which will be the data cleaning and the pre-processing, where organizing the collected data in structured format, eliminate the inaccurate, insufficient, and inappropriate data, which will enhance the quality, handling the missing values, remove duplicates, and normalize data for consistency. And the objective 3, which is the exploratory data analysis, EDA, where analyze the data using statistical summarizes and visualizes by using the graphs, plots, and heteroforms. Identifying the patterns, trends, and the correlations among the attributes like rainfall versus crop yield, vegetation indices, etc. And will detect and handle outliers or anomalies that may affect the predictions. Determine the future importance and the relationship between the different variables. And another objective, which is the cotton ball segmentation model by using the remote sensing data. Utilizing the high resolution images to extract the data about the cotton ball development, Apply the random forest method datasets to develop a segmentation recognition model. Focus on the splitting period, which is a critical, and the growth phase to analyze the ball distribution. So we normally will get to this higher resolution images from various satellite images, satellite data sets by using the IRS Dehradun data sets and its online sets. And we have the other objective, which is the crop production predictive model. We will use the machine learning techniques to train a model for estimating the crop production, split the agriculture data into training and testing data sets for better accuracy. Train the model using historical yield data, weather parameter, and soil conditions. And the next is the field yield prediction and the genotype selection automation, where we'll develop the yield field prediction maps, which will enhance the cotton breeding trials, automate the genotype selection process to optimize the cotton breeding efficiency, and implement AI-based tools to assist the farmers and researchers in decision making. The final outcome of this particular research, a well-structured data set for accurate yield estimation, segmentation model for identifying cotton ball distribution from satellite images, a crop production prediction model to enhance the productivity and planning, an automated yield production map to support better genotype selection. So now when come to the random forest method, which is the random forest method is an ensemble learning method and that construct the multiple decision trees during training and outputs the mode of their predictions. This approach mainly enhances the robustness and accuracy, making it particularly suitable for the complex data sets. The key advantage compared to the other conventional method is the computational efficiency. So here when we compare, we got the 96% of the accuracy, and which can handle the large data sets with the numerous features without the significant performance degradation, making it an ideal choice for the agriculture data analysis. Now, when come to the performance evaluation, so where the statistical metrics for accuracy and precision will be used to compare the field yield data which was seen and projected for each model, and the root map square, and which is expressed in the same unit as the predicted value, and the map which is used to assess the accuracy, which measures how close an estimate of the observed values. There is a large selection of algorithms available in machine learning. Usually they are separated into 4 categories: association, clustering, regression, and classification. The techniques for association and grouping go under unsupervised learning, whereas the techniques for classification and the regression fall under the supervised learning. When come to the results model, when the model predictions, our model has generated the yield predictions under various climate scenarios, revealing the critical thresholds beyond which yield declines significantly. These insights are vital for understanding the potential impacts of the climate change on cotton production. And we also done the vegetation indices analysis. We have analyzed the various vegetation indices with the different soil types by using the K-means clustering types. So here is the results. So for the particular soil area with the various field type with the various climate, we have achieved the 40% of the NDVI and the 60%, and the RVI is the 74.46%, and with the vegetation it is 25.4%. And for the field B, it is 87.79% and 12.21%. So the low vegetation health and the moderate, which is in the area, 0.3 to 0.4 variation is there, and the high vegetation health, which is ideal for the cotton growth, 0.6, 0.8. So this is the way we can able to help our farmers by using the prediction. Also in this project, we are by using the remote sensing data, we would like to make the app for the particularly for the farmers, which will be helpful for them, which particular soil type they can use for the cotton, and which particular climate will be suitable, which area, which land. So this will be really helpful for our rural area agriculture farmers. So this is
Ma'am,
also one we are focusing.
gentle reminder that you are crossing 9 minutes.
Yes, ma'am. So when we compare to the other cotton yield using the machine learning, our accuracy when we compare to the ANN technique, it is 86%, and the SVM technique, it is 75%, and the linear regression method, it is a 60% method. And when we compare to the random forest method, this is the 95% accuracy is there. So the field yield prediction and the genotype selection here, mainly we have developed the detailed field yield prediction maps, which enhance the efficiency of cotton breeding trials. And we are using the AI-based decision support, and also the research outcome is we are able to predict as well as generate the exact precision agriculture model for the farmers. And so our study is successfully demonstrated with the capability of random forest algorithm, which is the accuracy around 95%. So we are also the defining our predictive models further for the explore additional machine learning techniques. So I'd like to thanks to my organizations and the supporters and the many references, data sources to support to complete this research work. Thank you.
Thank you, ma'am, for your presentation. Archana, ma'am, the session chair is asking you, how does climate variability influence cotton yield in major cotton growing regions? Any specific machine learning algorithm we can use to overcome this issue?
See, as I mentioned here, we are using the random forest machine learning algorithm we used for this. And for the vegetation particular, we have used the CNN model. That is, it is not the particular CNN model. It is like a hybrid model of a CNN model we have used here.
All right. All the best, ma'am. Thank you very much for your presentation.
Thank you.
Next, I would like to call Ashok Kumar to present a study on turning AI against AI, the role of agentic AI in detecting and mitigating AI-generated cyber attacks. Ashok Kumar, sir?
Just a second, ma'am. I'm sharing my presentation. Just a second.
Yes, sir.
Mhm. Is it visible, ma'am? Is the screen
Yes,
visible?
sir. Yes, sir. We can see your presentation.
Okay, ma'am. Very good morning. I'm Group Captain Ashok. I'm a research scholar at Modi University of Science and Technology. My topic is turning AI against AI. As we know, the technology is evolved, and before it gets to the good hands, the attackers and the bad people start using it. The whole study is about how the AI, like large language models and all these things, have been turned to misuse the technology for attack purpose rather than defensive. Earlier, we could see, just a second. Earlier, we could see the phishing could be made out easily with the language. The audio deepfake required tremendous amount of compute. The machine learning attacks have made it possible to use very nicely, and autonomous bots which have been trained, they can take care of all these features. So AI powered phishing, if we are not good in English, a lot of SMS we keep receiving that, you can make out that this has been written in a language which is not normal. But with the advent of AI, the attackers have started using it, and they started modifying the language. So you can make out this is grammatically correct. The videos and deepfakes which they have created using AI, they are very genuine looking. The voice has been dubbed very nicely. In fact, President Obama's a lot of videos are roaming around on YouTube, which look very, very familiar, and the voice has been matched to the 100%. These attack methods, standard defensive mechanism, fail to detect them, because Gmail and Outlook, which is the most used mail client and mail servers, they can, AI phishing, it can be bypassed. Audio deepfake detectors fail across languages and models, because most of the languages, these LLMs have been trained for English language, whereas other languages, they fail miserably. Video deepfake detection, 50% area under the curve drop in the wild content. So since these methods are signature based and they are not adaptive, that's why these traditional methods of defense are failing. Now, the methods which attackers have now, defenders are evolving, which we have proposed in our study, that we start using agentic AI, wherein it detects autonomous detection, using autonomous detection, stylometric analysis, wherein it finds out what are the verbs, what are the pronouns. There is a standard pattern in a language wherein a person would be using noun, pronouns, verbs in a certain area. When it is AI generated, it has got different presentation. Just a minute. Side by side, agentic AI can do the planning, deception planning, wherein it can create a lot of honeypots, and attackers will be attracted to, a file which is attractive, and they would be targeting that, whereas a normal user would not intend getting into these directions. It generates human readable rationals, trust, and accountability, because usage of AI autonomously can lead to a lot of privacy issues. So when we use this agentic AI, we have to have all these factors incorporated. In the autonomous detection in action, with usage of Chat GPT-4, chat spam detector, we could achieve 99.7% detection accuracy with the explanation generation. And by using stylometric framework and XG boost accuracy, wherein we incorporated 60 features, including clause density, imperative verbs, pronoun frequency, we could detect that this AI generated phishing text is there. So while attackers are using large language models for their malicious purpose, defenders also have to start using and adapt AI for defense purpose. These are the strategies we have incorporated. Detection alone is not sufficient. Autonomous response is critical. Reinforcement learning defenders learn optimal countermeasures as machine speeds predict attack trajectories. The attackers are evolving every day. The attack vectors are evolving. Therefore, the defense mechanism cannot be static and signature based purely. So that's what we use in defense, moving target defense terminology, wherein it dynamically shifts IP addresses, environments, and various software versions. Side by side, it creates cyber deception, wherein known user would know, authentic user would know that this is not my area of accessing the data, whereas an attacker who is just carrying out a reconnaissance would be attracted towards it, and we would know from which IP address the attacks are originating, and those can be blacklisted. So with this, we could achieve 22% reduction in adversary success with deception is deployed strategically. human and AI teaming. So the question is, can we leave everything to the AI or agentic AI? Answer is no. Agentic AI is a partner. It's not a replacement, because we need to reduce false positive as well as false negatives. It means the explainability of the human readable rationals can build trust and enable validation. And the control has to be shared. Low impact mitigations, automated, and high impact actions require approval. Safe integration, it requires approval workflows, rollback mechanism, and continuous monitoring. How to build adversarial resilience is there are various frameworks available. We need to incorporate the new attack methods emerging and integrating in our system. We need to carry out red team simulations, time to time basis, and reinforcement our learning models, whatever we deploy. Deception diversity, rotate honeypots and decoys to remain unpredictable. The attacker should not be able to guess that this is our pattern of deploying, and it has to be a random. Resilience is a continuous process, not a one-time design. So now, what are the issues emanating in validating these systems? Is the data sets. The practice data sets in any of the lab tests and the industry production environment, there's a huge difference in getting a live data set and training the model.
Excuse me, sir. Gentle reminder that you are crossing 9 minutes.
Right, ma'am. I'm just closing it. This is going to be the last but not. So, tiered SOC validation, and we need to have cyber ranges wherein all attack patterns have been listed and users can be given to practice on that, so that when it actually happens, people are not caught unaware. We talk of agentic AI and autonomous deployment. We need to take care of civil liberties, privacy, accountability, transparency, and proportionality. Whereas considering that the agentic AI is a force multiplier, it transforms cybersecurity into proactive, resilient, and trustworthy discipline that meets AI era challenges while upholding accountability. With this, I come to the end of my presentation. These are the references which we used. Thank you so much.
Thank you, sir, for your presentation. The session chair, Dr. Archana ma'am, is asking you, how can multi-agent systems collaborate to defend against coordinated AI-driven cyber attacks?
Say it again, ma'am. Say it again, Sim.
How can multi-agent systems collaborate to defend against coordinated AI-driven cyber attacks?
Multiple AI agents.
Multi-agent systems. There are multi-agent systems. So how can they come together to defend against AI-driven cyber attacks?
As I said, agentic AI on a lower scale, when the attacks take place, response can be autonomous, but it has to be a good integration of human and AI. We cannot, as of now, if we leave it entirely to the agentic AI or any amount of training we do, there will be difference between training it on live data set and the lab data set. Lab data sets are not that authentic as on today that we can totally trust it. So we can, for the low response, low level kind of mitigation, we can leave it to AI. But when we want to have a high level of mitigation on agentic AI, we need to have a collaboration of AI as well as human.
All right, thank you very much, sir. Ma'am is telling you it was a very well organized and well presented presentation. All the best for your future work. Thank you, sir.
Thank you, ma'am. Thank you so much.
Now, lastly, I would call Naresh Kumar Joshi to present his study on design and analysis of an opposite rectangular patch frequency reconfigurable monopole antenna.
Yeah, thank you, ma'am. I'm sharing my screen. Not allowing to say why. Just not allowing.
Can you try again, sir?
Yes, I'm trying. Unsupported, please ask. Just a minute. Ma'am, just I'll drop and again rejoin. Better.
Yes, sure, sir. Wait for a minute until sir joins back. Yes, sir, we can see your whiteboard. You are muted, sir. Can you please unmute your mic, sir? Hello, Naresh Joshi. Am I audible to you? Can you please unmute your mic? All right, we'll wait for last half minute for Naresh, sir. Till then, I would like to give one last call to Hussain Sheikh and Manav Thakur or any of the co-authors who are present here. This is the last call to present your paper. All right, we'll move on with the closing remarks since all the presentations are done. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. So kindly cooperate with the team of ICTCS 2025. I would also like to thank our session chair, Dr. Archana Banet ma'am, for chairing the session. I'm sharing a token of appreciation to the chair on behalf of Team ICTCS and Global Knowledge Research Foundation and partners. Thank you very much for your valuable presence, ma'am. And I kindly request everyone to please turn on your cameras for a quick snapshot of this virtual conference. All right. Thank you, everyone. Have a great day ahead. Thank you, Archana ma'am. Thank you, everyone.